tank filming my Rampion wind farm here, and I'm just going to let that settle a little bit. for the faces that was built underneath, curving it like an arching skull. And I have a little light and candle mountain there. And then up here, pull, up, down, and down. Okay, so, alright, we have this laser here that's shooting into the tank here, and we have, of course, the GoPro that's inside the tank filming from within the tank. And then also I've marked out this little area here with tape and blue magic marker so I can reliably hold my cell phone camera, because it gets much better images than the GoPro's gonna. So I can hold it in here, and you can see that I have placed the little wind towers. We've got a blue one. Where's my pointer? There's my pointer. A blue one, white, red, green, yellow, blue, white, red, yellow. Whatever. And you can go with these. There's this toy modeling clay I got at Walmart. It's super cool. It's a lab-based modeling clay. It's lots of fun. And I just made little, they're pretty flat, but they stick up a little bit. Made little color dots all along the surface of the curve here. So you can see that I've adjusted the gradient. I've adjusted the density gradient until it's curved to light equal to, or very close to the curve that I have the fiberglass face curving at. And I've also set up the green laser so it kind of points approximately where the line of sight for the camera would be, the GoPro in there, and points at the little light off the screen. That's a visual representation of what the line of sight is going to be. And right now there's a pretty good gradient in there. And as you can see, we can see our little colored island, or colored mounds all along this curved surface. And I come right down. Okay, get it to focus. And we can see all the way. So like, see that yellow one at the very end? We can see that yellow one, and the green one and the red one, but the yellow one's the farthest. We can come all the way down to inside our little blue box, and we can still see that yellow one on the very far end. So now what I've got going on is there's a pretty big gradient at the bottom, and there's minimal gradient in the top. So my plan here is to turn on that garden hose and let the salt water start siphoning out at the bottom, and then film what happens to the line of sight and the visual view of that curved outlay of clay bumps as the refraction reduces and reduces. So let's give it a go. Looking here. Okay. Oh, those lights are sinking in the distance. Can we still see? Yeah, we can just barely still see. Wow. The farthest yellow one is just about to disappear. I have to come
come up high to see the yellow one, the farthest yellow one now. Okay. GoPro is still filming away. Now you can see that the whole field of view has dropped. Everything in the field of view has dropped. This is no longer that same strong lifting refraction. So see, come up, yeah, there's the farthest yellow one. Come down. Boy, it's getting clipped. Okay. Inside our camera view. Interesting. Let's have a look at that laser. Now the laser is picking up high in the sky. Let me see if I can tilt that down a bit. Yeah, now the laser's getting a little quick, but because there's size ridges on this little highway, see it comes up on the sides a little, you can see there's actually a bit of a trapped gradient in there. It's still causing a little bit of ducting, which is why we can still see a little bit of those lower lights just skimming through that there. But we can no longer see all of the wind farms like we could before. So it looks to me like the horizon is moving closer. I'm going to slow down that draining. Actually, I'm going to stop it and then let it stabilize. Let it stabilize a little bit. And then maybe set it draining, but not as fast. My little laser. It's only 300 milliwatts, but if you let it play on your thumb for long enough, you'll notice it. So you can see if I come up above the original camera position, if I come up high enough, okay, now I can see all the wind farm towers. But I start going down, and the far yellow one just disappeared over the horizon, and the red one went. Next two are gone. And I come down to within my little camera view here. Now remember, there were 3 lights visible. Now only the top light is just barely visible, and only 3 of the wind farms are clearly visible, although I see a few faintly squished ones right on the horizon, but hardly a clear view of them. And it looks like our GoPro is picking up about the same thing. The GoPro, I put a different lens on it because it would have been, just with a default wide angle lens, the little lights on the far end would be just, they probably would show up as a single spot. You really couldn't resolve them. So I put a longer focal length lens and focused it to the far end of the tank. So that's why it's showing everything blurry up close. But it is what it is. But my cell phone can focus. So now we've got a horizon that's quite a bit closer, showing really 3 of those blobs. Okay, and those 3 are here, which as you can see are kind of, geometrically, they should be visible. So I'm going to turn that water back on, see what we get. Let it drain some more. Oh, look, it's segmented its second card up. See, now that curved bridge, it's now looking curved again. Now if we get down really low, there's still some refraction gradient down underneath, but it's draining fast. From our camera perspective here, inside the little blue square I made for it, that farther metal thing is dipping lower and lower and lower. And now we're pretty much stuck with seeing just the three wind farm towers that we could see geometrically. But we can still see, let me zoom in, a little bit of the other ones all distorted and shrunk on the horizon because there's a little bit of strong gradient still captured between the two side rails on this curved surface, which frankly I wish those weren't there, but that's just the way it turned out. And it was something free I had, and it was the right size, and so I used it. But you can see that metal plate with the three lights, the whole plate was lifted up, and now it's dropping down more and more and more. And we have to come up quite a few inches now to see undistorted all of the little bumps of clay. You can see now the water in the tank has gone down quite a bit. I'm going to raise that laser up at this point in time. A little hand crank. Raise it up so I can level it right off this so we can see. Oh yeah, look at that. Now we can see that it's basically a straight line of sight now. So if I were to lower it, well, first of all, make it level, and lower it down to about the camera's eye height, you can now see that let me move the light. Not too bright to see the laser. You can see that the bridge would be cutting off, that the arc would be cutting off the line of sight. Now, in fact, you can pick it up a little to match kind of the surface. There. You can see that the laser would, or the light would get clipped off at the horizon there, and then this would be the drop over distance, and this would be the hidden type, and you can see that we would just see this piece of metal above the light. And I think that's pretty close to the GoPro. Yep, it's seeing just the metal above the light. And that's what we're seeing too, it's just a little bit of the metal above the light. Plus that little bit of, tiny bit of surface ducting. Well, okay. we're about out of water, and I'm going to raise the laser up a bit so you can see the light is basically going perfectly straight now. So, that's the guidelines on that one. Yeah, that's the long and the short of that experiment. We were previously able to see all of the wind towers from the clay bumps from this elevation right here inside this little blue square I made for myself. And now without that strong gradient, it's all sunk down. And actually I'm gonna shut off the draining now because we've gotten rid of the gradient that was above the curved surface, and I'm gonna let it stabilize a little and see what we get there. We are about out of water. Here's what you do. The green laser, every so often it turns the fan on to regulate its temperature. It's a little 300 milliwatt laser that works pretty good. Yeah, you can see it looks curved now, and it's like there's really not much. There's basically no gradient left. I drained all the gradient off the bottom, and now it's just the fresh water that was on top. Here's our little blue square. Yeah, see it's settled, and now those lights are just completely not visible. Well, one glimmers a little bit, the top one. And the wind towers are now, the ones that are beyond the geometric horizon are just gone. And we do see an upside down reflection there, but that's just the surface water. The total internal reflection of the surface of the water, which I can demonstrate by dipping my finger in. See, it's just the ripples. That's just the actual surface of the water. You know what I'm going to try? Now turning on the pump to put in more brine to recreate a density gradient, but this one will probably not be mixed correctly. It's probably going to be way too strong. So I'm going to pause the camera and try the pump to hold on. Look at this. See, fresh brine is coming in. Hasn't done nothing yet. Maybe I'll speed it up a little. So what if we get a bit of it? Yeah. I'm going to turn it on. super distorted because it's an extreme gradient boundary. And it doesn't want to focus because of all the threads floating. See, we can see the lights now, but they're getting compressed and stretched and sunny stuff. Well, I'll let the boundary or the gradient rise enough more here so that we can get a nice inverted total internal reflection mirage of the light at the end. These guys. Because right now the gradient is just right above the light. Maybe you let it get a little higher. Let's see what we got. This is my brine generator. That's salt and a pump and filters. Kind of like that, but shaped different. Okay, the brine level is right up here above the curved strip now. Now, because we've got, see how this laser beam is kind of straight? I guess you can't see it. Let me shut the light out. There. So you can see the laser, what? Oh, the crud is blocking the laser. Oh, that crud's really annoying. But, anyway, because up to right about here, below there it's all brine. So there's not much refraction inside the brine. It's all the same maximum density. Oh, but look, our little boat is floating up. Okay, let's see what we get over here. So from above, right now we're looking through the salt water down into the brine, but now we're moving down inside the brine. See, there's our little camera height square we looked through. Now we are seeing. Now you'll notice that we can see the entire surface of the bridge or the arch upside down, because, well, we can't see the surface of it because it's in the same gradient, the same density as us. So there's no gradient for us to bend the light between us and the surface, but the light is bouncing off of the sharp density boundaries above it. So we're seeing the entire surface upside down, including, you can see that the three lights are also upside down. And my laser just ran dead, it looks like, which that's too bad, because I was just about to show you something cool. Let's see. I'm going to pause the camera and see if I can fetch another battery to the laser. So, as you can see, we now have, I'm going to level out the laser, bring it up a little, keep tipping it over, bringing it up with one hand. You can see inside that brine, so you can see the brine goes right up to that brine right there. It looks like a yellow E on the top there. That's pretty much consistent brine phase, and that's why the laser beam looks pretty straight. So that's what we're looking through now. But you'll notice we can see in the reflection the surface of the curve and the lights in the distance upside down. So this would kind of be Fata Morgana stuff. It would be caused by a strong change from high density to low density. And I'll show you what the path of light is doing. When I point the laser up, see how it curves down? So there's the path of the light from the, if it's from the lower light, let me point it at the lower light. Okay, it's pointed at the lower light. That requires you to point the camera up to go down. So like, let's see if I can capture this. See, when I point the camera up, the laser beam goes down. When I point it down, the laser beam goes up because it's reflecting off of that total internal reflection. So that's why that looks upside down, is because the light is crossing paths. I point it up, and it points down. I point it down, and it points up. That's what makes it look upside down. So when we see a Fata Morgana, a ship upside down, that's quite likely the cause. And so we can see here, actually this is interesting, we see our lights upside down, but then we see a reflection of them right side up, which is probably them reflecting, because see, we're seeing also the ramp, or the curved surface upside down. So what we're seeing is it's a shiny black surface, so we're seeing a reflection of the light upside down, which puts it back right side up. And then of course we go up further, and where's the, yeah, up there, that's the actual surface upside down reflection, but down here is all the gradient induced reflection. So there you go. Well, that went longer than I thought it was gonna. So hope you enjoyed that.